So we're going to have Matt come out here, and he's going to talk about dependency management, I think. Am I right, Matt? Yeah? Yeah? I think it has something to do with Docker, but I'm not sure. So we've gone full Halloween here at DevOpsDays Madison. I have to like see where I'm going. So here we go.
Hey, how's everybody doing today? Happy Halloween. So, hope you're doing well. As was alluded to, I might be talking about Docker today. The actual name of the what's that doing? Because I'm not. Or we're not going to. All right. So we'll just leave it like that. So the talk I'm giving is containing dependency nightmares using Docker. And you know, one of the things I want us to do on Halloween is to not be scared and to have some fun. Obviously, having a little fun out here like this. So first, before I begin, I want to say thank you to the sponsors and the conference organizers. I think I've been having a great time so far. Has everyone else been having a really good time? Enjoying it? And as I said, you know, the organizers and the sponsors are really helping us. Before I get too far, I want to talk a little bit about who I am. I graduated from Madison. I've lived in Madison for about 16 years now. I've been working there since 2001 and full-time since I graduated. I'm a developer for the campus messaging system, and I work on our deployment tools. That's what we're going to talk a little bit about today. And we've been using Docker for about 1.5 years. And as I've been rehearsing this, I learned something that cats, specifically my cat, don't find Docker nearly as fascinating as I do. I think at first she was really interested, but then a little less so, trying to distract me. I think it went out to full-out boredom. We've been hearing so much about Docker. And I hope this isn't a suicidal attempt at this point. But, you know, that's not what I want any of you to feel like. I think we should have some fun. One of the things about DevOps, I think, is that really the cultural changes and the work-life balance and just making work a little bit more enjoyable, as you think I might be able to, you know, talk a little about. So the goals for today, I know some of you probably use Docker, some of you have heard of it, haven't used it, maybe are on the cliff about whether or not you should start it. And I want us to have a basic understanding of what it is if you haven't gotten that yet. And then also for anyone who's on the cliff about whether or not to use it, to feel comfortable watching a couple examples that you're able to start using it to take them back, doing some simple things on your own. And also then, for anyone who's used it or is still thinking about it, you know, that we're going to look at some examples that I've gone through and some problems I found, and then how to avoid some of those pitfalls. So hopefully everyone can start using it without issues. The way we're going to do this is I'm going to take an iterative approach and cycle through what I built, and then what was wrong with it, how we use some containers or something like that to fix it, and then we'll move on and repeat over and over and over. Well, not that many times. So the example I'll look at is automated change records. As we're switching to continuous deployment, with small changes being deployed frequently, sometimes you know, a couple times a week or a couple times a day or many times a day, we're making small changes that we want to go out constantly, and we don't want anything interfering with those. Our service management team, on the other hand, you know, still wants to be documented and notified when the changes are happening. You know, they use change records for that. So we needed to find a way that we could get those going out constantly without any issues. So what we were doing is automating those change records there. And at first what we did was we took just a Perl scripted module that calls our change management's REST API, and it was a pretty simple process. It was authenticating, it would get a JSON object with the template of the change record, and then it would update the values from there, and then it would save it, and then it would log out. So pretty simple process. There's a little more complexity we'll talk about later, but nothing too fancy. Though at first we just wrote, you know, a module to do the Perl module, and then a script to call it. Though there were some problems with this, and that's that not all the languages or libraries, the dependencies you need are always available. So our environment is pretty heterogeneous. We run on Solaris, Linux, and Mac, and Windows. Mac's the only one we don't run. And of course, Perl is available on any Unix or Linux things, but not already on Windows. then the other thing we'll run into is that some of the libraries we need, for example, JSON, may or may not be installed by default. So you're going to need to add those in there. And the problem we had is on Solaris it wasn't available, and because this is our deployment tools, we have kind of a chicken egg problem where we would normally use those to make sure the code is going to be, or the libraries are going to be installed, but we can't do that from itself and know that they've already been installed. So I went on a really bad example and wrote my own JSON parsing module, which was not fun. I would not recommend for anyone. So the other thing that we're going to talk about, and I'm sure you've all seen, is your upgrading code or changing things that different applications are going to require different versions of libraries, and sometimes you're going to upgrade and break something else, and we just want to have to avoid that if possible. So if we can get into present mode real quick. So, yeah, possible solutions that, is we could use the deploy tools to install things, but that's going to be that chicken egg problem. We could ask someone else to do it, but again, it's just pushing the problem down the road. So, what are we going to use to solve these problems? And that's, I'm going to say, is that we need something that's going to be complete with everything we need, and it's going to be the same, consistent, that it's going to run, exactly the same anywhere, no matter where that is. So if that's on a development machine, or in the cloud, or running, Linux, or running Windows, the same thing is going to happen. And as you may have figured out from what I'm wearing and what's on stage, I'm going to recommend Docker containers as the solution to that. So, straight from their website, the definition they have is Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications, whether on laptops, data center, VMs, or in the cloud. So I highlighted the developers and sysadmins. I think this is really important here to why Docker is so important to the DevOps community. Because, if it's your development laptop, or if it's an operator or a sysadmin running this in, a data center in the cloud, it's the same thing. It's basically blurring that line between the different people, saying you're all using the same things, the same people can be doing the development and the operations work. There's no difference anymore. So then Docker runs what are called containers, and they're what wraps a piece of software in the complete file system. I'll let you read this. And what that allows is it's going to run the same regardless of it is. So that's the advantage behind containers, because everything is packaged together. So I just wanted to give a little example here of what this looks like if you're not familiar. So on the left, you've got the without containers. Where you have your host or VM, you have the operating system, and then everything is kind of separate. You've got the applications you're running and the dependencies. Say, for example, that application 1 requires dependency 1 and dependency 2, but it's using a specific version 2a. Application 2, on the other hand, might need dependency 1, 2, and 3, but what if it needs a different version of dependency 2? That may or may not be possible. Maybe you can specify a different path. Maybe that's, the application doesn't allow that. So you might run into a challenge with that. The other thing you may run into is that sometimes you can't have another instance of an application if you need a different configuration or running. Sometimes that works, sometimes it doesn't. Again, it's going to depend on the application. With Docker, on the other hand, you've got the same host and OS setup, but underneath that is running the Docker engine, and from there, you'll see that the applications are all bundled together with the dependencies. So in this case, application 1 can have the dependency 1 and 2a that it wants. It can also, application 2 on the other can have its own version that it wants. And the other thing is that there's no problem with running another instance. The containers are all isolated. They don't know what's running in the other containers. So, as I said, we iterate through. What I had so far was the Perl module and scripts, and I'm going to move that to a container. But before I did that, I hadn't been familiar with containers at the time, so I wanted to do something that was really simple just to get my feet wet with containers. And if you haven't started using them, I'd recommend a similar approach. So the example I did was a really simple one that I'm guessing is in most of your code. It's just something that would send emails. So even if you're using, a system library or something like that to send emails, there's still probably a couple lines of code that's setting up the connection and maybe authenticating, it's constructing your message, then sending it, and then error checking at the end. So the same, dozen or so lines of code are going to appear there, and you want to put those either in, a library or method of your own, which means that everywhere you're going to need to send that email, you're going to need that dependency there. The problem with this is that if you need to make a change, say you weren't authenticating to the SMTP server before, but now you are, now you need to go update that library or make changes to that, redeploy that method everywhere you've got it out there. The solution, though, is if we can make this a container, now there's one thing that's running that we can access, and everything is going to be packaged together. So we also don't need to worry about installing any libraries or things that would be needed by that. It would just be one thing that runs just like a command or a script that's going to take care of everything. So I just wanted to give you a brief example. This is a Docker file, which is one way you can construct the images that run, that are a collection of files that are going to run the container. All of the Docker files are layered, so you start with something and then you build on from there. In this case, I'm starting from Perl, but you could start from an operating system or an application or any other language you wanted. There's tons of them available for download. And then, so you start from there and then you're going to add onto there. So the maintainer is who's maintaining this contact information. The run commands are actually running the container and then making an action happen there. Any command that you would normally run on the command line. In this case, it's installing a couple modules. And I want to point out, it's also cleaning up at the end. A big important thing to do is make your images as small as possible so that they have a tiny footprint for running. And if you do that just one time at the beginning, that's going to affect every other instance of this you're running. Finally, we're copying in the module I wrote and the script that's running, and then at the very end, it's actually running that script. So that's what's going to be listening, parsing the parameters from the user that actually sends the message. So to call it, it's really simple. You're doing a Docker run command that actually run the container. I'm cleaning it up and not leaving it running at the end. And then each of those -e lines is an environmental variable that's passing a parameter into the container. So the to, the from, the address, the subject, etc. And then at the very end, it's what is the image that's running. I just want to point out, if you're not familiar with Docker too much, that those tags are just labels on there. Latest doesn't mean anything specific unless you happen to call each one the latest. So that was pretty simple. It worked. Took me maybe a couple hours to get going, and now I have some confidence with Docker. So now I switched back to the automated change records, and I switched that in a similar fashion to moving it into a container. So it was just copying those modules and scripts in, and most things just worked as I would have expected. And the really nice thing here is that I was able to finally get rid of that homemade JSON parser and use one that was maintained by someone else other than me. So that was a nice thing. The problems I had is that there was a lot more config with this one. There were a lot of just different object IDs and relationships and credentials that needed to be there. And that made it a little more tricky than the email one, where the only config you might have is maybe what server or port you're connecting to, maybe credentials. And one of the things I always say is never to build the config into your images. The images are immutable, they're not going to be changing. And if you want something that can be exactly the same wherever you're deploying it, then you can't have those config, especially not the secrets in there. If that was viewable by someone else, I would try not to have that in there. So what I like to do about this is then, pass them in at runtime. There's a couple ways to do that. So you can pass them in just like I showed in the previous example with environmental variables, or which is fine, and until you start to get a lot of things that need to be passed in. That's going to be the problem here. The other issue with that is if you're doing secrets, that those are going to show up in your history or in a process table, and you wouldn't want anything sensitive showing up there. So another way around that is that you could have environmental files that you basically define the variables that are going to get loaded into the environment. So that's one way. You can lock that down in permissions to just the user that's running Docker can use. A similar thing is you can make volume mounts. That's also a way to get information out of containers. So if I would use this if you had an entire directory you might want to mount in. You can also do it just on a file. But anytime you want to transfer a lot of information and have it available on the outside and inside, that's a good way to do it. Of course, there are also a bunch of secrets and configuration management tools. If you've already got those in place, you may be able to work those so that your containers can access them. But the big drawback here is that still the user has to worry about the config. Why, when we're setting this up, should the user, when all they want to do is make a change record, should they have to worry about how we're dealing with the config? So another couple more problems we have is that, this was running as a Docker run command, which means we can only access this on machines that had Docker installed. For us, that would be fine on Windows and Linux, not so good on Solaris. I've never tried to install Docker on Solaris, and I really don't ever hope to. So what we've done is we've replaced the library dependencies with Docker as a dependency, which isn't a great thing to do. And we've just, also that whole string of -e's isn't really an elegant way of passing the parameters. So what I'd say is that Docker, can help us package everything together, but it still might not be the best user interface for calling things. And we can do better on that. So what I did the next time around is I made this microservices and that are web services. So just since there's a lot of different definitions of microservices, I wanted to give a definition I'm using here, that they're small single-purpose web services. That they're going to use common lightweight protocols, often HTTP or HTTPS. From that you can run that pretty much anywhere, any language you want, you can make a web request. And that in terms of size, the best definition I heard that I like is that there's something small enough that they can be thrown away and rebuilt in a small period of time. So a couple days, maybe a week or two. This, if you lose the developer that maintains something, 5 years later you need to figure out how to deal with it. If it's just too much of a pain, it's only a couple days to redo it. Or if you want to try a new technology, it's pretty easy to go in there and say, well, it's not a big investment to swap this out, play around with something new, and if it works, it does, great. If not a huge loss of time. It's not like you're changing a huge monolith that took years to develop. So, a little bit about how we implemented it. We have a web service wrapper that, again, this is in Perl. It's using Dancer as the framework, which loads the config and the libraries, and it does the objects. The nice thing here is I'm adding something new, and I haven't had to change anything. The scripts and the modules that I made have basically been the same throughout. All we've been doing is adding on new pieces and new layers. Twiggy is the web server which handles web requests. Again, another thing we're adding, but we're not changing anything that we've made before. Now I can get Docker to handle loading the config at startup, so the user doesn't need to worry about that as passing any parameters or files. It's just going to happen when the user makes the web service call. And all we're doing is then going to expose that code as a method, and it's going to run similar to if you were just calling it on the command line, but now via the web. So I said all the user needs to worry about is making the web request that's going to supply the parameters that they wanted for making the change record. Nothing else. So just an example, you don't need to really understand this, but there's not much here. All it's doing is setting up an application and the config. And similar type thing, all we're doing is I've passed in the, as volume mounts, the configs on that cat line, and we're just putting those together into the format that our framework wants. And then we start up a web server. Again, we've passed in the keys via volumes. So there's nothing really fancy or new going on here. I haven't had to write any new code. It's just setting up things. And of course, you can do whatever language or framework you're happy with. The cool part is, though, for the users, it switched from that kind of long Docker run statement to just doing any kind of web request where you've got the parameters in the string. So real simple there, nothing for the users to worry about. So this is getting a little better for them. So as you're starting to use more and more containers, what I'm finding is that if there's a change you want to make, just like if you were to change a library, now you need to go through and update all those containers. So the way I would avoid this is to use that layering approach again, and then instead of basing off of a standard image, a Perl or whatever language or OS you want or application, to then insert your own between with your own customizations and always build from there. And you may use multiple layers as well. So for instance, we have a handful of languages we start with, and then we've got certain sets of customizations. We're always going to add users that we're running in that are root or different utilities that we want available. And we'll do those at those base levels, and then everything that we build bases off of that. And all we're doing is copying the specific libraries or scripts that are needed for that application. So to keep things at the lowest common denominator. Another place that we find we use this a lot is, on the when we're doing security scans, if there's a vulnerability, we can just update that one specific thing in the top level image that we have, and then all we need to do is a rebuild of the children, and we don't need to go through and run any commands or any fixes there. So it saves us a bit of time there. So. I just wanted to go back through and highlight a couple of the takeaways just to reinforce, hopefully everybody can use this. Either if you're already using Docker or if you're on the fence, that you'll feel comfortable. So why use the containers? You know, they package everything together, which is going to provide you with consistency and portability. Another thing I didn't mention too much, but they make it really easy to get up and running with something. It used to be that if you had, you know, if you wanted an application, a web server for instance, you'd have to install that, set up all the config on your own, and it might take you hours or days. Now often it's a matter of minutes and you can have a web server up and going. So if you want to play around with something, if you want to just try something out, you know, you can do that really, really quickly. You know, again, I would really recommend, you know, biting off small pieces. Don't feel like you need to take your most complex application and just move it to a container. Take something that's really small, maybe kind of a, you know, a trivial, useless example at first, and then put that there. Once you're familiar, you know, make bigger and make bigger changes. The cool thing is that containers are really easy to update. So where you used to have to worry about, you know, are all the files going to end up in the right place? Are you going to have problems when you upgrade something to break something else? Now all you're doing is stopping the container that's running the old image and then starting running the new one. So it's, you know, really just 2 commands and you're running the next thing that you upgraded. So it's okay to do that many, many, many times. And I'd recommend using, you know, microservices, a good interface to them. Don't feel like you always have to be, you know, calling Docker directly to run your containers. If they get too large, split them up. You know, that should be kind of well adopted by now. And then, you know, use the microservices and the containers to feel like you can modernize and change things as needed, test things out. I always say, you know, keep things simple. Make sure you're using the layers to avoid any duplication. And then where I think we're getting now is that as the components get smaller, the complexity shifts to the interaction between them. So instead of having one monolith that ran everything, now we're having tons of little containers that are all interacting with each other. And there are orchestration and configuration management tools that will help you with that. That's beyond the scope of what I'm going to talk about, but I think if you start to use containers, know that that's something you're going to want to look at pretty soon. So, yeah, thank you for listening, and hope you guys learned something today. And with that, I got just a few minutes left for questions. So. Yeah.
Are you the only one managing the Docker knowledge base?
No, we've got a team of about half a dozen of us, and oh sure. The question was, am I the only one running the Docker knowledge, our Docker knowledge base? No, we've got a group of about half a dozen people, and this is kind of my role then to get involved with some of the deployment and testing and trying some of this out. But now, you know, most of our developers are pushing their code into Docker and, you know, using the same thing. So, and I actually took, you know, from what some of the other people developed. So, anything else to break there? Yeah.
Are there any challenges with, you know, getting Docker, you know, accepted in a large government, you know, organization?
Yes, tons of them, and we're still struggling. It's not perfect. Actually, oh, sorry, the question. Yes, were there any challenges in getting Docker accepted in a large government institution at the University of Wisconsin-Madison? Yeah, we wanted to just go forward with this, but there was a lot of pushback at first. Is it secure? You know, just I think a fear of change in general. But from the talk yesterday about, you know, is security, does it have to be perfect, or can we just do better than nothing? And I think that was our thing, is we said, hey, like, look, if we had all these applications running before, and, you know, they may have been getting looked at, maybe not, you know, can we do stuff now to help you see, you know, that we're making improvements, we're going forward, you know, that's a little bit better. And at least now we're easily able to keep things up to date. Where if we had, you know, a web server, it could get, you know, quite a few versions out of date. Now it's really easy to just say, yeah, we'll just roll the newest one up, you know, as often as we get to it. No? Or break time. Yeah.
There are any wrapper restrictions for the scripting, like what's the install for the Docker container? Are there any restrictions? You use only code, but is there any other scripting language you can use for the wrapper?
I think, yeah, the question is, are there any other restrictions on the web service wrapper, the framework we use in terms of the scripting and code? You know, you can use whatever you want and package in front of it. So if you're already familiar with any other language or framework, you can just move that in there. This is just what we happened to use in the past, so we stuck with it. You know, I don't think we're in the majority of people by using Perl. It's just that we've been using it for a dozen or 15 years, and we had a lot of code with it, so it's easy for us to move that with the knowledge we had. But definitely, anything you have, you can move. And the nice thing is on the Docker Hub or the Docker Store, a lot of stuff is already available if you just search for it. Someone's probably built what you're looking for.
Way in the back.
How do you know if you're, like, the images you're using are secure and safe? Are you guys scanning them, or what are you using?
Sure. How do we know if the images we're using are secure and safe? Yes, we are. We are doing two things, and I'm remembering one of them right now, but we are scanning. One of them is we're pushing them back to Docker Hub, and they'll do a scan for us. And then we've got another one I'm not thinking of, but if you send me an email, I can look it up and let you know. But yeah, we're doing a couple scans. One's a bench test, and they run and they tell you if the containers are, if there's any known vulnerabilities. And that's what we're doing with the security, is then we send that off to our security group, and they'll look over that and let us know, what they think we need to address. We've done a number of other things, as standard practices, making sure that we're not running as root or locking down permissions, things like that. And that's what I put in those base images that we customize, so that we only have to do that a couple times, kind of one for each base we're starting from, and then we don't have to do that in every single image we build. Cool. Well, I can't see you guys too much, so thank you for listening.
All right.
Have a great break.